With this outreach symposium, our intention is to give you, the audience, a scientific view of the different forms of energy that do and can play a role in the future energy mix of the world. As researchers and educators, we also would like to give new impulses to high school teachers and their students, and to our colleagues who are teaching at the undergraduate level, to think about what kind of physics skills to focus on, so that the next generation of physicists has what it takes to contribute successfully to solving challenges in the field of energy. And to paraphrase the introductory words of the book Energy for Future Presidents, what we are going to do in this symposium is to temporarily set aside the politics and focus on energy objectively, so that hopefully you will get some new clear insights, even though they might be surprising at times. And that brings me also to our first speaker, our guest of honor, Richard Muller. Richard is an emeritus professor from the University of California, where he has held a faculty appointment since 1978. And concurrently, he has held appointments at the Lawrence Berkeley National Laboratory in California. Richard has, is a fellow of the American Physical Society and of the American Association for the Advancement of Science. And he has received multiple awards during his career, of them the Texas Instruments Founders Prize, the National Science Foundation L&T Waterman Award, and the MacArthur Foundation Prize Fellowship, to just name three. Having started as an elementary particle physicist during his PhD that he received in 1969, his work and during his career, he has branched out into a multitude of topics ranging from cosmology to geophysics. His interdisciplinary work has often focused on the unexplored interfaces between well-established disciplines, and he has also been an entrepreneur by founding the data consultancy Berkeley Earth and being the chief technology officer of the Deep Isolation Project. Richard's multidisciplinary portfolio ideally positions him to tackle a topic that is as diverse as it is relevant, and that is energy, the topic of our symposium today. With his best-selling book, Energy for Future Presidents, he has written an insightful tour de force on different forms of energy that provides the reader with a quantitative guide to disentangle all the headlines that are related to energy you're usually confronted with in the news. We are really thrilled to welcome Richard to this outreach symposium here at the 2021 Fysikermøte, the meeting of the Norwegian Physical Society, and we're really very much looking forward to your talk. Please, Richard, share your screen. The virtual stage is yours.
Well, thank you very much. It is a great honor to be the first speaker at this symposium. It's also a challenge. I will do my best to tell you, not cover the material that you already know. Many of you know a great deal about energy. I'm going to try to focus on those aspects of energy that are essential to know, important to know, and yet which are widely either misunderstood or not known. I wish I could have been in Norway. I had planned to come. You can see beautiful Berkeley behind me. It's a little bit dark there right now, and the city lights aren't that bright. But I would have much preferred to have a Norwegian backdrop at this point. Let me share my slides. The science of energy. So I wanted to begin with aspects of energy that you may not know that much about. And let me begin with something extremely practical. Our love affair with gasoline. This is something we're all battling. Everybody thinks gasoline is bad. Why is it so hard to break up with gasoline? Whoops, let me figure out how to go to my next slide. I can do that down here. Now, we don't love gasoline because of its smell. It's and yet we seem to be addicted to it. This, by the way, is an illustration of a little picture book I did with Joey Manfrey called The Instant Physicist. It has 100 different little anecdotes, each one of which is a surprising fact that you can use to win a bet with a friend and illustrate it in a delightful way. It's something for younger people who want to be amused, or older people who want to win bets. So why do we love gasoline? Take a look at this chart. This is the energy per gram for different materials. A bullet, which of course is lots of energy. There it is. It's 40 joules per gram. It's only 1.5% the energy of an equal weight of TNT. So we don't always use things because of their energy. Now, an auto battery, it's only 5% of the energy of TNT. Not surprising, TNT has a huge amount of energy. Let's get up here to, well, the TNT itself, which is a really good battery. A rechargeable computer battery has about 15% the energy of TNT. But now take a look at gasoline, which is down here. It has 10 times more energy per gram than TNT. That astonishes most students of energy when they learn it. You learn all about the abstractions of energy, about energy conservation and so on, but these numbers are very fundamental. Look at coal. Coal has, it has 10 grams per 10 times the energy of TNT. Gasoline is 15, if I have it right here. Yeah, gasoline is 15. Makes it very hard to give up gasoline. Think of gasoline. Go back 100 years from now and imagine what it was like when we had our first gasoline engines. Where I grew up in the Bronx in New York, my home, my house, my big apartment building was heated by coal. And every week they would pile coal on the sidewalk and the workers would shovel it into the house where it was burned for a week. And then they would shovel out the ashes and then a truck would come by and haul them away. But look at gasoline. You pour it into your car and when you're finished, it's gone. The only thing it produces is this wonderful stuff called carbon dioxide. That's what I thought when I was a kid, which helps plants grow. So what a miracle gasoline was, this huge energy content, 100 times the energy content of the battery. Now we're struggling with this now as we're trying to make battery-driven automobiles because you need a lot of batteries. And there's no way around that compared to gasoline. Batteries are a bit more efficient than our gasoline engines, and that helps. But still, you're fighting this factor of 100. And that's something to appreciate when you are thinking about these various energy sources of various fuels. Hydrogen is also has even more energy. Here it is. Hydrogen has 40 times TNT. It's almost 3 times as much as gasoline. The trouble is it's not as dense. And so it's a much larger volume, especially if it's of gas. But even as a liquid, it's not very dense. So per volume, gasoline is still the winner. That's why it's so hard for us to break away from gasoline. And one way we do it is with much more fuel-efficient automobiles, of course. So here I'm just highlighting those numbers. Gasoline is 15. Oops. Batteries, we are 100 times factor. So our love affair of gasoline is because it's convenient, it's clean. Well, we used to think it was clean. We used to think carbon dioxide was okay, and it's relatively safe. Okay, let me move on. When I retired, my daughter and I created a consulting company to advise countries on what they should do about energy. And it was actually Bangladesh who contacted us and they wanted advice on how to handle their role in global warming. And I said to my daughter, I'm not even sure global warming is real. the data that's been published by the International Agency for Climate Change has problems with it that I'm aware of. And how do we advise Bangladesh when I'm not even sure it's right? Maybe global warming is twice as bad. Maybe it's half as bad. Maybe it's not there at all. I was a skeptic. And in my first book, Physics for Future Presidents, I think this is where my skepticism was reflected. So she suggested that if we're going to advise countries on this, we better figure it out. So put together an independent team of top scientists that would take an objective look at climate and convince me whether global warming was real and how bad it was. So we did that, put together an astonishingly good team. At Berkeley, you just gather up people. I was looking for people who had not made up their minds, who were aware of the valid arguments made by skeptics, and I can give a whole talk on that. And I'll include some of that today, and who were mathematically adept, ideally people who had not only done science, but actually made discoveries, because that's the real measure of a scientist. If you've discovered something unexpected, that means you're doing a really great objective job. So I got the team together, and it took us 2.5 years to put together a completely new database, something that wasn't manipulated by any other scientific group. And that's shown here with this background curve. We went all the way back to 1753. The gray curves represent the uncertainty limits. The thin black line is the data. And you can see the data. Look at this thin black line. It bounces all over the place. This is for a world average. The fact that we can go back so far is truly astonishing. And then it rises here. And this is what, when I saw this, I said, my God, there really is global warming. We've done all of the corrections that the thoughtful skeptics had insisted on, and which had not been done in a clear and transparent manner previously. So really proud of this paper. Next question is, what causes it? So I tried various things. I remember thinking, let me just fit it to a mathematical curve, an exponential. Actually, it didn't fit very well. How about a polynomial? Well, that didn't fit very well. Exponential plus a polynomial. Well, that fits better, but that's because you have more parameters. You don't want to have a lot of parameters that becomes meaningless. It's just a mathematical fit. I looked at world population density. I looked at other things. And finally, Robert Rody, who is truly a genius in data analysis and in getting data. We collect these data ourselves off the web from people who had put them up, the raw data. He said, Rich, why haven't you tried carbon dioxide? I said, oh, of course, let me try carbon dioxide. Bingo. This, except for these dips, that's the carbon dioxide curve. It was the first fit I tried that actually matched the data. No elaborate modeling, no compensation for 36 different corrective factors, no adjusting of the data, 2 parameters, the overall level and the sensitivity to carbon dioxide. Bingo, wow. At this moment, global warming is not only real, it's caused by humans. Because we know from carbon-14 dating that the carbon comes from fossil fuels. It doesn't have carbon-14 in it. It's so old that the carbon-14 is all decayed away. And then Robert said, let's put in volcanic eruptions. So we have a record of volcanic eruptions. In particular, we have records of dust from the upper atmosphere. So we just took that one record and put in one more multiplier, and there it is. And you could see these volcanic eruptions. They cause short cooling periods, but they're only short cooling periods. And each one of these dips has a named volcanic eruption. So without having to do the elaborate computer models. In fact, I have to confess, the computer model community criticized us severely. Our model was too simple. It's what physicists do. We try to see if something can be explained simply. It didn't require all the adjustments, all the inclusion of everything. They say, if you don't include everything, you can't prove anything. But this curve, I have used this to convince more skeptics, I think, than than you would imagine. I tend to like to have meetings with skeptics, and they say, "Oh, well, what did you do about the urban heat island effect?" And I say, "Oh, here's what I did. Here's the paper. Let me show you. We did this, this, and this." And, "Oh, that's pretty good." What about data selection bias? "Oh, yeah, we adjusted. Here's how we handled data selection bias. We used all the data. There's no selection. We didn't change." I mean, the best one of the groups used only 6% of the data. How did they choose it? Anyway, so we did all these things, and bingo, global warming is real, and we published this, and I can convince any skeptic who will listen to me. And if there are any skeptics out there, let me convince you, global warming is real. Although I'm going to tell you in a moment a paradoxical statement. I'm going to argue that climate change is mostly not real. I want to draw a distinction between global warming and climate change, and that will prove to be important. So let me, having done this, what do we do next? Well, we started looking into air pollution, and there's a good reason to look into air pollution. And by addressing air pollution, you can actually solve most of global warming. I'll get to that later. But my daughter, Elizabeth, who's now my boss, because she's the CEO of our nuclear waste company, my daughter, Elizabeth, suggested that what we should do now is apply the same objective approach to looking for solutions to global warming. And so that's what we have been doing, looking objectively. We don't come in with a solution, we come in with the problem and ask what solutions can address that problem. And that's really what much of the rest of the talk will be. So I wrote an op-ed for the New York Times, the conversion of a climate change skeptic, which gave me a certain degree of fame and notoriety. But it made other skeptics very interested in what I say. And as I point out here, what we showed was that global warming is real. But there are many things attributed to global warming which are not what the proponents say. Floods are not increasing, droughts are not increasing, hurricanes are not increasing, tornadoes are not increasing. I'll come to that in my talk. So skeptics, when I talk to a skeptic, I listen to him for half an hour, and then I say, I agree with everything you said, but you didn't mention global warming. Oh, but all these other things. Yeah, well, a lot of them are just exaggerated. What about global warming? It's real. Here, let me show you. Is it a danger? You know, I cannot put objective science behind saying it is a danger. I believe it is a danger. I believe we're getting into a climate, well, no, we are getting into a climate regime that civilization has not been in. The Earth has been in it. I'm sure the dinosaurs would like it if it got warmer. But civilization has not been in it, and that really concerns me. Making a change as big as that is going to affect civilization in a positive way or a negative way. I know people who argue it'll be positive. There's no good scientific argument against them. I am just cautionary. I think a big change, I don't want a big change. I kind of like the Earth the way it is. So based on that, I'm dedicating my life to stopping global warming. And that's based not on science, that's based on my gut feeling that this big change, which based on science is going to happen if we don't stop it, could very well be bad, and that's bad. Okay, so the projected temperature rise, this comes straight out of our data. It's going to go up another 1.5 degrees by the time the CO2 reaches its double level. And that's simply because we're proportional to carbon dioxide. And when we double the carbon dioxide, it will go up this much. Now, some people will say, oh, that's not much. But the ice ages, which were really dramatic, was a temperature drop of only 6 to 10 degrees. So 1.5 degrees more is big, and there's nothing that's going to stop the CO2 doubling if we don't act on it. So yes, I think it is a very significant rise, but you don't need complex computer programs. The skeptics are fascinated to hear this, that these really complex computer programs that put in everything, and they worry that there are 100 adjustable parameters in there. And I say, well, you don't need them. Look, just look at the curve. 2 adjustable parameters, it goes right up. And this allows us to predict, and there's the prediction. So we want to do something about global warming. Now, why are there skeptics? This is a map I made in which I took the United States. I also did it for the world, but I couldn't find my old map of the world. And what I did is for every location in which there was a good temperature record going back 100 years, I fit it to a straight line to see whether it shows warming or cooling. And the red crosses are all the locations that showed warming over 100 years. The blue circles, which I think tend to show up a little bit better here, are all the locations in the United States where the weather has cooled over the last 100 years. I get people calling me and saying, I don't believe in global warming. In my town, we have the record, it's gone down. And I said, oh, you do? Well, would you like to have a list of 100 other towns in which it's gone down? But I thought we had global warming. Oh, I can give you a list of 200 towns where it went up. So global warming is not something you can tell by walking outside. It's not something you can tell by, looking at your thermometer. Global warming is an average effect. That still has impact, but it's an average effect. And to think that every local effect is due to global warming, well, first check and see whether or not your local temperature has cooled or warmed. Odds are 2 to 1 that it's warmed, but it may not have. So here's a fact that almost nobody knows unless you've read my book. And it's important. And these local variations are what we call weather or microclimate. Okay, sea level rise is real and is due to global warming. That is one effect that is really due to global warming. If you look how much it has risen in the last 130 years, it's gone up 20 centimeters. It's not showing any clear evidence of acceleration, although there's a lot of argument on this. People they make a big deal because they would like to say, oh, it's accelerating, and they'll find data. By the way, in the United States, most of the discussion of sea level rise has to do with Florida, where it has gone up much more than this. But of course, that's not sea level rise. That is Florida sinking into the ocean because everybody's using up the freshwater aquifers that are beneath the surface. So when you see regions where they say our sea level rise is more than 20 centimeters, that's undoubtedly sinking of the land. Don't confuse that with sea level rise. These data are available online, and you can look at them, and it's an issue, but it's not going to flood Bangladesh. It's not going to cause. There are a few islands. If you don't spend trillions of dollars to stop sea level rise, when sending a few $1 million to an island will now enable them to put up levees. I had a friend of mine, Peter Tans, who was working with me for a few years, and I joked that he was interested in global warming because his country is below sea level. And he said, no, Rich, we know how to put up dikes. We're not going to have any trouble. That's not my reason. So the sea level rise is often exaggerated, but it causes constant worry. Hurricanes are not going up. I have lots of data on this. You can read about it in my book. People look for some statistic that sounds bad, so they find, oh, wait a minute, here's one. The strongest winds of the strongest hurricanes have gone up a bit. Yeah, okay, but the number of hurricanes has been going down. I mean, you can always find a statistic to make things look bad, and beware of that. Beware of someone who searches through all the literature and finds something that sounds bad and then attributes it to global warming. Global warming theories, some of them predict hurricanes will go up because there's more energy in the oceans and in the air. Some of them predict hurricanes will go down. And the reason is hurricanes are created by the difference in temperature between the equator and the poles. That difference is expected to drop with global warming. In fact, we've been seeing it dropping with global warming. That reduces the force that creates the hurricanes. So be very careful here. Watch out for the biased reporter who takes everything that's bad and attributes it to global warming. Often there's no scientific basis. Or you'll hear some people say, some scientists predict. Oh, what? Look at that language. Some scientists predict that hurricanes will increase. Yeah, and some predict it'll decrease, but the commentator isn't mentioning that other half. So these are particularly interesting in the United States are tornadoes. And I had an op-ed in the New York Times pointing out that tornadoes have not been going up. Again, this isn't a clear prediction of global warming, that violent storms will increase. If you asked 30, 40 years ago, people would say, well, we don't know. I believe the honest scientist today still says, we don't know. But you will get the news reports that scientists say tornadoes are increasing, and they attribute that to global warming. And what's left off is, and other scientists disagree with them. And the issue is completely unsettled when you look at it objectively. So global warming is real. It's a cause for concern. I am dedicating my life to stopping it. But that doesn't mean that every bad thing that's happening in the climate is due to global warming. There are many cycles. I wrote a technical book on the ice ages before I got into global warming. I studied the ice ages. I studied their origins. They come about due to orbital changes of the Earth. And so because I'm an expert on this, I'm a good person to answer the question. Many skeptics say, how do we know that this isn't natural from orbital changes in the Earth? And I said, oh, I've calculated it. It's not. Ice ages are due to changes in the orbit of the Earth. We have these cycles, 100,000-year cycles. That we know comes because the Earth, the tilt of the Earth is changing slightly. The eccentricity of the Earth is changing slightly, of the orbit. But no, global warming is not part of that. Global warming is happening much faster than ice ages. Ice ages take thousands of years to start. We're seeing global warming taking place in 100 years. Sometimes people say, well, won't this stop the next ice age? And I say, well, the next ice age is due any millennium now. So no, this is happening much faster. And the carbon dioxide is going up much faster. It will not stop the next ice age. Here's some more data. This you hear all the time in the United States. Alaska is melting. This is the mean temperature in Alaska, and you can see the rise. And there are pictures of trees. They call them drunken trees in Alaska because their roots are, the ice is melting. And so the roots no longer have support and the trees fall over. And I've been up to Alaska and I've seen these drunken trees. And so Alaska is melting. But if you look at the data, there's something fishy here. Break it up into two parts. It looks like a step, doesn't it? That step is actually statistically significant. So attributing this to global warming, you need to look at other things. And it turns out there are some old papers that were published. This was a paper published in 1970. No, this was published in, 2004, if I'm reading it right. I can't quite read it on my own screen. Anyway, around 2000. And this was a paper that looked at temperatures in the northern Pacific Ocean and had very precise measurements of temperature in the northern Pacific Ocean. And noticed something really strange happening in 1977. There was what it calls a regime shift. What's a regime shift? Well, those are well known in oceanography. It typically means that there's some deep circulation. Here in Norway, I'm sure you're aware of what is often called the Gulf Stream, or the thermohaline circulation. And this circulation is unstable and it tends to rise in the North Atlantic and then flow back. I'm sorry, the other way around. It flows to the surface up, warming Norway more than you deserve, and then dropping down and coming back. But that drop-off point is unstable. And if it drops off sooner, then you don't get as much warm. So this is what they think was happening around Alaska. Here is the temperature in Fairbanks. It shows that regime change. Does this mean global warming isn't real? No, global warming is real. I can show you it's real. I can prove it's real. I put my scientific reputation behind showing you that it's real. But it does mean that people who say Alaska is another example of this are guessing. Maybe this regime change is actually a rise like that. Maybe that's statistically unlikely as a rise like that. But beware of these arguments that people make of what will happen in the polar ice region in the next 30 years. We'll lose all of our polar bears. You know, that is all trying to get you excited about global warming. It's an attempt to get you worried about global warming. It's not science. And we in this room, in this large virtual room, are scientists. And the worst thing that we can do is to lose our credibility. When the public assumes we are going to give them the objective scientific analysis, and nothing has done more harm than the whole global warming debate, the climate change debate, to causing science to lose its credibility. You know, fight that. Be objective. Don't accept everything as due to global warming, but you can show global warming is real, and I believe a cause for concern. I don't put my scientific reputation behind that point. I just put all my work and time into doing it. It led us into some interesting directions, which I will touch on later on. Now let's see if I can, yeah, okay. Oh, so I show this again. Don't be too surprised. Look, things are highly variable. Okay, what this is, Steve Koonin wrote a book that's been highly controversial, but it has really good data in it. And this data looks a little bit fuzzy to me right now. Didn't realize that when I copied it over. Steve's a good friend of mine. But the data is really worth looking at. Whether you believe his conclusions or not is a separate point. And this shows that the drought conditions in the United States really haven't changed in 100 years. Not surprising. Look how little the temperature has changed and how variable it is. Why would you expect drought conditions to change? Sorry, I don't have this for Norway. This is flooding. You hear a lot every time there's a flood, someone will say, and this could be due to global warming, or this was made worse by global warming. We had these big hurricanes. Hurricane Sandy hit New York City, and it flooded New York City. In fact, my daughter, who was living in New York City, has a video looking out her window showing an automobile floating by. Astonishing. And everybody said, well, this was due to a big hurricane, a low pressure system over the United States, but it was exacerbated by global warming. Yes, it was exacerbated by global warming. The 10-foot rise, the 3-meter rise, was an additional 3 meters plus 10 centimeters because of global warming. 10 centimeters being half the temperature what it was since people remembered in the 1950s. So it's a gross exaggeration to blame what happened in New York City on 3 meters and 10 centimeters, so much worse than if it were just 3 meters. I mean, these are the kind of exaggerations that drive me crazy because it seems almost every time Al Gore, who is the most exaggerator of all the exaggerators, was giving a talk on global warming, it always happened to hit a cold spell where he was. It was ironic. A burning area, again, I apologize for the fuzziness of the curve, but the burning area is going down. We're not getting bigger burns than we used to. Lots of data. I got some for England and Wales here, the winter rainfall. It's cut off a little bit on my screen. Let me close my window here a little bit. Okay, and you can see, oh, maybe it's going up a little bit. Look at the data. You recognize most of the public looks at a plot like this and they have no idea what to look at, what to see. They studied plots when they were in elementary school or high school or something, and they haven't looked. They don't look at them again. Many newspapers refuse to have plots in them because they just turn people off. But you can look at these plots and you can see what's going on and you know how to interpret them, and it's your duty to do so before you talk about the subject. So when someone asks you a question and you think you know what you read in the newspaper, but recognize when they're asking you a question, they're not asking you because of what you read in the newspaper. They don't want you to pass on what the newspaper said. They're looking to you because you are a scientist or an engineer or a technical person, and they are expecting that you have looked at it. So be honest and say, well, I haven't looked at that, but I will. And then look at it. Don't pass on newspaper opinions. Newspapers are trying to sell papers. They're not necessarily trying to be objective. Oh, here I am again. That's just saying all these things aren't surprising. Okay, so I mentioned data selection, but okay, here we go. So this is global. This is the carbon dioxide increase, and Keeling is famous for having done this. There's a yearly cycle. Yearly cycle is averaged up there. Yearly cycle, it's simply because there's more land in the northern hemisphere than there is in the southern hemisphere. Twice as much land in the northern hemisphere. And so the growing pattern is not uniform during the year. When it's warm in the northern hemisphere, you get carbon dioxide being taken up, and when it's cold, the carbon dioxide comes out. So these cycles are due to the northern hemisphere, but it's really rising, and it looks like it's accelerating a bit. And the issue is, can we really control that acceleration, or can we do something else? At Davos one year, I led a study in geoengineering. We had top people from all around the world. And we had one group in my team who specially was going to be to worry about the human effects of geoengineering, throw dust up into the atmosphere, put iron into the oceans, do something else that'll stop global warming. So we had 5 different teams, and all of them studied geoengineering. And then we had a report, and every team came forward and said, we oppose geoengineering for the following reason. Nobody in the Davos team was in favor of geoengineering. Why? Because of the unexpected side effects. What could happen? So if you want to geoengineer, the way you geoengineer is keep the carbon underground where it is now. Stop pumping it into the atmosphere. Don't try to do something to compensate for the temperature. So you will hear people talking all about the possibilities of geoengineering. But my team at Davos, which had very thoughtful, very smart, very knowledgeable people, nobody wanted to do geoengineering. Okay, back here again. I brought this back just to remind you, global warming is real. And it's simple to show. And all of the objections raised by the skeptics, we have really good answers to it. Just look up the paper published by Berkeley Earth, berkeleyearth.org. That's the website. Here it is, down here in the lower right-hand corner, berkeleyearth.org. And you'll get the paper and lots of other things. You'll get an hourly update on air pollution, a daily update on global warming. So I'm really proud of having created this nonprofit with my daughter, Elizabeth. Okay, so this is why, given all those things that people are saying which are false, I tend to refer to global warming and climate change separately. Climate change includes global warming, which is real, includes sea level rise, which is real, includes storms, droughts, and floods, which are not, or at least not demonstrated, and may be the opposite. When the data finally get good enough, we may see that storms, droughts, and floods are actually decreasing. We don't know. So I recommend that you be skeptical of everything other than global warming and sea level rise. And both of those are due to human-introduced carbon dioxide into the atmosphere. We know that because the additional carbon dioxide is low in radiocarbon. That shows it comes from fossil fuels. Besides, we know how much fossil fuels we dump into the ocean. Okay, so solidly established and much exaggerated. So here we are again. Now, who to blame? Well, the US. In the US, we've contributed 0.4 degrees Celsius to global warming so far. Europe has contributed 0.5. Oh, but that's a lot of countries. Yeah, okay. But global warming has been 1.5 degrees. So this is gigatons of carbon dioxide. And you can see what's happening here. But I'm willing to take the blame. It doesn't matter who you blame. The amount of global warming so far is not enough to be noticeable. When people say, I want to be compensated for global warming, maybe your temperature went down over the last 100 years. It's so highly variable that you can't even detect it unless you're a scientist averaging hundreds of sites. So putting blame is a cheap thing to do. And in the IPCC, they want to make the United States pay for all the damage done so far. We've only done 0.4 degrees Celsius, come on. And the warming just hasn't been that big. Let's get out of the blame game, although we can take the blame, and look at the future. Now, this is the future a few years ago. This is up to 2013. And what happened is that in terms of production, China produced more. It hasn't kept on going up. It's leveled off, largely because they're using hydropower instead of adding new coal. And I'll show you that data in a moment. But now they're getting back to coal. They've saturated in hydrocarbon. They're growing. And so they dominate in the new production. Oh, but they have a bigger population. Well, wait a minute. This isn't a blame game we're talking about. What we're talking about is what can we do? And if you ignore the biggest creator of carbon dioxide, you're not going to solve the problem. This is what's happened in the United States. And what you can see is that coal produced in the United States has dropped significantly. Again, this is not completely up to date, it's even more. Natural gas has gone up. And because of that, US emissions have actually gone down. So here are China emissions. This is more or less up to date. And China has been leveled off here for hydropower, but now it's starting to build coal again. So I expect it to go up. The USA has been pretty level and then been going down. And Europe is on here too. India is one to watch. As India develops its economy, as China develops its economy, I expect this to go up unless we get them to use alternative sources of energy. And that's really important. By the way, people say methane is also a greenhouse gas, which it is, and it gets way too much attention. And the reason is methane in the atmosphere has a very short half-life, about 8 years. And so you can dump a lot of methane into the atmosphere. It's not going to contribute to long-term global warming. Of course, if you keep on producing it, it does contribute its 10 or 15% effect. But in the long term, switching to natural gas and holding back on the leaking of natural gas into the atmosphere, burning it is fine. Produce a little bit of carbon dioxide, but that's not really significant. Leaking it into the atmosphere is bad. And that can be controlled through regulation, and it needs to be. But in the long term, methane is not going to be a big factor. This is one of these little known facts that my daughter and I wrote several scientific papers, peer-reviewed journals, just pointing this out so someone could point to a peer-reviewed journal that says, no, methane is not going to be the problem. And to the extent that we can get countries to switch to natural gas and get them to do it without leaking, which is technically not hard to do, then switching to natural gas from coal is an enormous effect. It is enormously beneficial. I've actually spent some weeks in China trying to help them switch from coal to natural gas, which they desperately want to do. Now, this is a famous plot. Energy per GDP. So this is how wealthy the country is per person, and this is PPP, purchasing power parity, and this is the energy use per person. And you can see if you were Mexico or India or China, you'll look at this plot and say, I want to be up there. And so your planning, your economic planning will be to have more energy per capita. Now, some people say, look, the US has increased its GDP while going horizontally. So you don't have to, China, you can go horizontally. And say, well, okay, maybe. But for now, I'm going to build more coal plants because going horizontally is expensive. And our GDP has gone up. We have conserved a lot of energy. Our population hasn't grown that much. This is a plot that you cannot ignore if you're talking to someone from the developing world. This is why they are planning on having more energy any way they can get it. What we have to do is make it profitable for them to get that energy in a clean manner. We can't just say, don't do it, don't have the energy. In fact, people say, well, we should set an example. Yes, we should set an example. We have set an example. The example we've set is it's really nice to be wealthy. And China and India and Mexico, they'll say, I want to be wealthy too. And when I'm wealthy, then I can start spending a lot of money on cutting down carbon dioxide. But being wealthy helps in education, in health. It helps women's liberation. It helps everything. Being wealthy is your first step, and that's the problem. If we're going to solve this problem, this is the total carbon dioxide projected from here with a reasonable projection. And then here's the bad news. Here's the U.S. Now, the bad news is, suppose in the year, this obviously is not up to date, but suppose in the year 2025, US goes away. we go completely solar and wind, and manufacturing carbon dioxide goes to zero. We go to zero. What happens to the total? The total drops. The production drops. Okay. And then what happens? It drops, and then it goes on up. If the United States were to go away completely, if we become zero emissions, then global warming will be delayed by about a year. So no matter what we do in the United States, we cannot stop global warming. Likewise in Finland. Setting a good example, we've set a good example. It's called wealth is good. We could try to drive down the cost of clean technologies. So here we get to solutions. So here are my key insights, and you may quote me on these. Any effort to reduce emissions is futile and possibly counterproductive unless it sets an example that the developing world can afford to follow. So if we put on a carbon tax, is China going to put on a carbon tax? Oh, God, there's so many people who say, yes, they'll do it because they're worried about global warming. You know, they're also worried about their economy. A carbon tax, they say, is revenue neutral. Yes, it is revenue neutral. It's not cost neutral. The purpose of a carbon tax is to make ordinary fossil energy more expensive so that you are willing to buy the more expensive clean energy. So it's not cost neutral. And we're not going to push this on the developing world. They're not going to do it because the other issues of a better healthcare, a better standard of living is more important to them. So here's the way I like to phrase this. If it isn't profitable, it isn't sustainable. Look for technologies that the developing world will adopt because they are profitable. Now, I believe such technologies exist, and they are the key to slowing and stopping global warming. Okay, a little bit of sarcasm here. If you're worried about global hunger, there's something you can do at home that will increase the number of calories per capita on the earth. So you think that would help hunger? Well, have a big breakfast and you'll eat more calories than you would. Then on the average, the earth calories will go up, the average person. Having a big breakfast is doing something at home. And they say, think globally, act locally. Well, no, acting locally often doesn't work. Having a bigger breakfast, even though it increases the average nutrition of the average person on the earth, doesn't stop world hunger. Okay, electric cars. Boy, I get more hate mail on electric cars than anything else because in my mind, they just don't work. If you include in the extra cost of the battery, it's costing you more per mile, more per kilometer than a gasoline car. Work out the numbers. So you have to spend $10,000 more in the United States for an electric car compared to a gasoline car of similar performance. $10,000. That the battery eventually runs out. It has a finite lifetime. Tesla has a nice trick. They guarantee the battery, and they will replace it. What they do is they charge you $10,000 extra up front, and they have a battery all waiting for you that you've already paid for. So when your battery runs out, you get a new one, but you pay that premium on the Tesla car. So even worse, if you were to switch to all electric cars in China or India, you're running those cars not on electricity, you're running them on coal, the coal that produces the electricity. So it doesn't do you any good to switch to electric cars in the parts of the world that matter. Remember, if you're not focused in on the developing world, you are not addressing global warming. Okay, so feel bad measures. These are really popular in the United States. Ironically, this was our President Jimmy Carter, and we had an oil crisis, and he said, be patriotic, put on a sweater and turn down your thermostat. He did more harm for energy conservation than any president in the history of the United States. What he did was he told people in the United States that energy conservation is uncomfortable. And it doesn't have to be uncomfortable. Energy conservation is the biggest thing we can do to stop and slow global warming. And it doesn't mean put on a sweater and turn down your thermostat. What I tell people is don't put on a sweater, put a little more insulation into your walls, turn up the thermostat to whatever you want, but have insulation in there. Within 3 or 4 years, the energy savings will pay back the cost of putting in that insulation. And you'll be using less energy. And it's energy conservation, but it's comfortable conservation. Never tell anybody to suffer for energy conservation. You do that, you are teaching them that energy conservation is uncomfortable. Here's some good energy conservation. These are chandeliers at Notre Dame. I took this picture. Those are compact fluorescent bulbs. In Notre Dame, in Paris. Well, before it burned. They'll probably now replace them with light emitting diodes. And here's another thing. See these cars? Those have infrared reflecting paint. Cool paint. They're dark blue, but they reflect the infrared. Automobile manufacturers do this so that they can reduce the air conditioning fuel required for air conditioning, which gives them more miles per gallon, which means they can advertise more miles per gallon because you have to include in the air conditioning. So by using this paint, you can use this on roofs too. You don't have to have white roofs. You can have dark blue roofs and save energy. So energy conservation is the biggie. Now, solar power, I'm running short on time, so let me just go quickly and say there's a growing opposition to solar power in the United States for 2 reasons. One is once the cells go bad, they are too expensive to recycle, and the pollution in them is quite considerable. The other is they're heavily subsidized around the world. There is also an issue of backup. They only work 1/6 of the time, 1/6 of the sixth of the time, because the sun is not up at night, and it's grazing light in the morning and dusk, and there are clouds. And so wind, there's strong objection to wind in the United States now that it's becoming practical. They say it industrializes the landscape. It's noisy, it has all sorts of other problems. These are not, I don't think these are really good solutions. So keep this in mind when you hear talks on solar. People will talk about the capacity of renewable capacity. When you have a gigawatt solar plant, they'll say that's the capacity, right? That's when the sun's right overhead. On average, it produces 1/6 of that. So in the talks that are coming up, if the speakers give you the capacity and don't tell you what the average power is, interrupt them and say, hey, okay, so let me skip this because I'm running out of time. Advertising capacity of solar is 1/6, 1/3. This is all being recorded. So nuclear and coal. Okay, China is a renewable powerhouse only because of its enormous hydropower. And China is not an example that we should follow. They're destroying the environment with hydropower, and they have actually very little solar. So beware of people who say, let's follow China's lead. They're really doing enormous damage to the environment. Air pollution is horrible in China. It comes largely from coal burning. If we can switch them to natural gas or to nuclear, we will have a bigger effect on stopping and slowing global warming than anything else we can possibly do. Anything that's on your charter today. If you can reduce coal emission in China, you get rid of the air pollution, but you also get rid of the global warming. It's amazing. If you switch to natural gas, the particulate goes down 2,700 compared to 7. Natural gas does not produce the PM 2.5. Okay, so here's the solution. And the only solution I have found in trying to be objective on this issue: energy conservation, Keep in mind, this is highly profitable. I see more energy conservation when I travel in India than I do in the US because they can't afford the more expensive energy. Nuclear energy, we've got to go with nuclear energy. We've got to build it up. It's the quickest thing in much of the world where you can replace coal, And people say, oh, but wait, nuclear waste storage. Well, it's not difficult. And this is what my company is doing. In fact, we just signed a contract with Norway for the Erdo countries to do an investigation of what kind of nuclear waste can be stored using our deep borehole method. And finally, natural gas instead of coal is a really big step, a real big advantage. Nuclear power, and China is going ahead with nuclear, and I think the rest of the world too should. So the waste problem. So this is our method for nuclear waste, and it turns out nuclear waste, the worst nuclear waste, is in long, narrow cylinders that conveniently fit down boreholes. And this is our solution to nuclear waste. Put it 1.6 kilometers deep and store it down here. And we've done all sorts of detailed simulations. When you're down below a billion metric tons of rock, the stuff just cannot come up. In a million years, very little has reached the surface. You can satisfy safety conditions by over a factor of 1,000 safety factor compared to the already stringent safety conditions. So this is what we have a contract with Norway, NDD, to look at and to evaluate how much of their waste can be stored in this way. So key points in summary, and I think that's the last slide. Yep. So let me just leave that on. I'm sorry I didn't leave much time for questions, but thank you very much. And maybe I should stop screen sharing at this point.
Thank you very much, Richard.
Yes.
Thank you very much, Richard, for this thought-provoking presentation. We have already gotten some questions here from the audience and both online and locally. Let me start out with the first question from Mehdi Belhaj. He would like to know, what do you think about runaway climate effects, this concept of a runaway climate effect?
Oh yeah, no, that's real. No, runaway is a real concern. Now, it has an interesting history because there's been a long series of things that could run away. Everything from methane clathrates to just the feedback of ice melting and so you have more warmth and so on. There's the one about the thermohaline circulation. Wally Broker had a paper about that. An interesting history is every single one of them has basically been discredited. Now, that doesn't mean, I mean, when looked at scientifically, the initial cause for worry has been shown not to be valid. Now, what scares me is that people keep on thinking of new things. And that's really scary because we don't understand the climate. And there may be something, so I think we should take it seriously. We should take seriously the fact that runaway climate change may happen, not through a mechanism that's been stated. If you start saying, oh, it's going to be the overturning of the thermohaline circulation, some scientists will say, no, let me tell you why not. And what do you say? But the fact is, we don't know the climate well enough to be able to predict this. Therefore, we should really be concerned about it. But there is a danger here that we will rush into quick solutions and not do the long-term solutions. People say, we've got to act today. And nothing is more harmful to long-term solutions than a rush to say, well, we don't have time to develop new things. We've got to use what we have today. So we've got to keep on thinking long-term. We've only gone up 1.5 degrees. And in the next 60 years, we'll go up another 1.5 degrees. I think we have time. I don't think, from what I've seen, we should not use the danger of a runaway as a reason to rush to action.
Thank you. We have a comment. Trond Kvamstad from NTNU, one of our speakers later on wind power, wants to put forward in a Norwegian perspective, namely, what about offshore wind power? I mean, this seems to have a few of them.
That's where the wind is. It's great. It's expensive, typically twice as much as putting it onshore. And so I'm in favor of wind. If you don't object, I think windmills are pretty. Every time I drive by in California, I see these windmills up there. I go, ooh, that's pretty. People are beginning to object to it. They like the rolling hills without wind turbines on them. So you're going to have an environmental problem. And we have offshore wind proposed on the East Coast, and all people are objecting. They worry that it will affect the whales. No, it doesn't affect the whales, but they worry about that. And you can't convince them it won't affect the whales. So there are all sorts of problems that are coming up. But I think offshore wind is a real winner. Winder, is that a pun?
Very.
Offshore wind is the way to go, particularly in Norway. But remember, you're not addressing global warming.
Because it's the solution.
Because you're not talking about similar conditions in China and India. So hey, if you can get cheap, if this is cheaper than nuclear, great, use it. But if it's more expensive than nuclear, why bother? You're not helping global warming. You're only helping global warming if you're making something that would be profitable in China, India, and Malaysia, and the rest of the developing world.
And that's a call for development of the technology to make it more affordable and generate any.
The wind potential offshore is enormous.
Great. There was another comment / question from Diana, and so she takes from your talk that somehow social inequality between countries is an issue when it comes to global warming and mitigating its effect, and it appears difficult to fathom what, as an individual, one can do in the developed world to help this process.
I would say what the individual can do is vote for the right politician who has a thoughtful approach to this issue. I think my talk was full of social equity issues. And we can't tell India and China that they should take on expensive solutions. But if we can find profitable things for them to do, as I said, in India, they're already adopting compact fluorescent light bulbs and LEDs. And they do that because they can't afford expensive energy. So those are really great. Energy conservation is really great. India is also messed up in some mistakes they're making having to do with outlawing air conditioning and other such things, which we could talk about separately. But no, we cannot tell the developing world what to do. We have to set an example that shows them. In the United States, we're doing the opposite. We are saying natural gas is not safe. That's what our president says. It's terrible. Imagine you're in Bangladesh and they say, and the science advisor says, we should have nuclear power. And the president says, nuclear power in the United States, that's not even considered safe. We are setting just the wrong example by being opposed to two of the most important solutions, natural gas and nuclear. And that's doing far more harm than anything we can do to put in to drive my own electric automobile, or put in my compact fluorescent, my light emitting diode lamp right here. So now what we've got to do is not only think globally, but act globally. And act globally means there's not much you can do in your backyard. There really isn't. I'm sorry. Those things just make you feel good. And doing feel good is bad because then you're not addressing the real problem. You've got to vote for people who will address the real problem and will support those technologies that can actually solve the world problem.
Do we have any further questions from the audience? Yes, Bjarne Stugu is asking, is nuclear waste a potential energy source in the future?
Yeah, it is. But the amount of nuclear waste we have is far greater than any amount that we think we might use. The issue here is that nuclear waste still has a lot of uranium in it, has plutonium in it, and that all has more energy in it. The problem here is that it's actually cheaper to get new uranium than to reuse the waste. And when you reuse the waste, you're not decreasing its radioactivity. You're producing more fission products, and those don't go away. You're using the uranium and the plutonium, but you're making more fission products. So it's false to think that when you reuse nuclear waste, you're actually decreasing the radioactivity. You may be decreasing the long-term radioactivity, but even not that. The iodine-129 is still there. The chlorine-36 is still there. So you can use it and you can recycle it, but you're not reducing the waste issue. And it costs you more than just getting uranium. The Japanese have now developed a way of getting uranium out of the seawater. And it looks absolutely cost competitive, which means we're never going to run out of uranium. And in the end, we may be using fusion 30 years from now. And then we won't need the uranium anymore. But we're not going to run out of uranium. And recycling the waste doesn't really reduce the amount of waste.
Thank you very much. Any further questions? I don't see any. Then we really thank Richard once more here from the auditorium.
Thank you. I wish I could stay for the rest of the session, but it's now 10 minutes after 1 a.m.
Yes, so really thank you for joining us at this late hour. Thank you very much. Bye-bye.
Okay, thank you.